Welcome to my channel. Today we are going to derive the expressions for time of ascent, time of flight, maximum height and range. Before going to this concept, let me say two important points that are useful for this derivation. The first point is, if speed is constant, the only formula that we use is speed is equal to distance by time, or distance is equal to speed into time. So now here speed is constant. What does it mean? That is acceleration is 0. Now, to this case where acceleration is 0, if you use equations of motion, then also we'll get distance is equal to speed into time. That is, even if you use s is equal to ut plus half at square, since acceleration a is 0, then you will get s is equal to u into t, which is nothing but distance is equal to speed into time. Okay, that's first point. Next point is, if speed is not constant, that is, if the body is moving with some acceleration, then we can use equations of motion. Okay, now let me consider this body, this as a projectile. Now I throw this projectile with a velocity u from the horizontal. This velocity u can be resolved into two components, that is u cos phi along the horizontal direction, u sin phi along the vertical direction. Okay, as the body moves from 0 to a, what will happen? The vertical component of velocity will decrease, and at point a, the vertical component of velocity will become 0. Whereas the horizontal component of velocity remains constant throughout the path, that is from 0 to a and a to b. If we come to vertical component of velocity, at the point a, the vertical component of velocity will be 0, and as the body moves from a to b, the vertical component of velocity will increase in reverse direction. Okay, and this point where the vertical component of velocity is 0 will call it as maximum height, and this distance from O to B will call it as range. To know why the vertical component of velocity decreases as the projectile goes from 0 to A, and why the vertical component of velocity increases in reverse direction as the projectile goes from A to B, and to know why the horizontal component of velocity remains constant throughout the path, and to prove that the path of projectile is parabola, click on the link given in the description. Okay, now let us come to our derivation. The first derivation is derivation for time of ascent. What is time of ascent? The time taken to reach the maximum height is called as time of ascent. Means, what does it mean? As I project the projectile with the velocity u, what will happen? The height increases as the projectile goes from 0 to a, and at point a it reaches its maximum height. So this time taken by the projectile to go from 0 to a is called as time of ascent. Or the other way of defining the time of ascent is the point or the time at which the vertical component of velocity is 0 is called as time of ascent. That means we know that as we project this projectile, as the body goes from 0 to a, the vertical component of velocity becomes 0, and this time taken by the projectile where the vertical component of velocity becomes 0 is called as time of ascent. Okay, now let us go to the derivation. Let us think in terms of vertical direction. Along vertical direction, the initial velocity is u is equal to u sin phi, and at a we know that the final velocity will become 0, and acceleration a can be taken as a is equal to minus g. Since g is in downward direction, so we can take it as a is equal to minus g. Or if you use sign conventions and if you take upward direction as positive, since acceleration due to gravity is in downward direction, so I can take a as minus g, whereas rest of the quantities are in upward direction, that is along the positive direction. And t, which is nothing but the time taken by the projectile to reach from 0 to a, that is nothing but time of ascent. Okay, so t can be written as ta. Now I will use the equation v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Now according to our logic, final velocity v is 0, initial velocity is u sin phi, a is equal to minus g, and t is equal to ta. So 0 is equal to u sin phi minus gta. Now if I take this u sin phi towards LHS, then what will I get? I'll get u sin phi is equal to gta. And if I do some mathematical calculation, finally I'll get time of ascent ta is equal to u sin phi by g. That is, the other way we can write this expression for time of ascent as ta is equal to uy by g, which is nothing but the initial vertical component of velocity by acceleration due to gravity. Okay, this is the formula for time of ascent. Time of ascent ta is equal to u sin phi by g. Now let us go to the derivation for time of flight. Before going to this derivation, let me explain you what do you mean by plane of projection. What is plane of projection? The plane that is passing through OX, or the plane that is passing through OP and perpendicular to y-axis or perpendicular to your screen is called as plane of projection. So this is called as plane of projection. Now let us go to this time of flight. What is time of flight? See, if you see this expression, if you see this diagram, what I am doing, I am projecting this projectile from this plane of projection. As the projectile starts moving, it leaves the plane of projection and reaches its maximum height and again reaches to its plane of projection. Okay, this time taken by the projectile to leave the plane of projection and again to reach the plane of projection is called as time of flight. So what is the definition for time of flight? The total time taken to reach the same horizontal plane of projection is called as time of flight. Okay, next. So now if I project this projectile from this plane of projection, what will happen? It goes into air. So it goes into air, reaches its maximum height and again reaches to the plane of projection. Okay, so between these 2 points, that is between the point O and point B, it remains in air. Okay, this total time for which the projectile remains in air is called as time of flight. Okay, now let us derive the expression for this time of flight. Now let us think in terms of vertical direction. Vertically, the initial velocity is u is equal to u sin phi. S is equal to 0. I'll explain why I wrote S is equal to 0. And if you use sign conventions, or if you take, since G is in downward direction, so I can take A is equal to minus G. T is nothing but the time taken by the projectile to move from 0 to A and A to B, which is nothing but time of flight. So I took it as T. Now the point is why I wrote S is equal to 0. So now if you observe, vertically as the projectile goes from 0 to A, what will happen? The vertical displacement will increase and at A, the vertical displacement will reach to its maximum height, which is nothing but capital H. And as the projectile moves from A to B, the vertical displacement will again decreases and becomes 0. That is, as the projectile goes from 0 to A and then to B, what will happen? The vertical displacement will increase, reaches its maximum height and then decreases and again becomes 0. That is, as the projectile goes from 0 to A and to B, the vertical displacement will be 0. That is why I wrote S is equal to 0. Now I am using the formula S is equal to ut plus half at square, where S is nothing but the vertical displacement during the time of flight, which is 0. U is nothing but the initial vertical velocity, that is u sin phi. T is nothing but the time of flight. A is minus G and T is T square. Okay, now when I substitute all this, what will I get? I will get 0 is equal to u sin phi into T minus half gt square. And if I take this u sin phi towards LHS, then what will I get? U sin phi into T is equal to half gt square. And 1t gets cancelled. And if I do some mathematical calculation, I'll get the expression for time of flight, which is nothing but T is equal to 2u sin phi by g. Or the other way of expressing this formula is T is equal to 2 into initial vertical component of velocity, that is uy by g. Okay, so this is one way of deriving the time of flight. Let us derive the expression for time of flight using other concept. That is, so first we know that Ta is nothing but the time of flight, which is nothing but the time taken by the projectile to go from 0 to A. Similarly, the time taken by the projectile to reach from A to B is called as time of descent. Okay, now this time, that is this time of ascent, will be equal to time of descent. That means the time taken by the projectile to go from 0 to A will be equal to the time taken by the projectile to go from A to B. Okay, so that means time of ascent will be equal to time of ascent will be equal to time of descent. Okay, now this total time of flight can be written as T is equal to sum of time of ascent is equal to time of ascent plus time of descent. That is, T is equal to Ta plus Td. And as we know that time of ascent is equal to time of descent, so this total time of flight will be equal to T is equal to 2Ta. That is twice the time of ascent. We already know that the expression for time of ascent will be 2 u sin phi by g. That is, the expression for time of flight will be 2u sin phi by g. Now let us derive the expression for maximum height. As the projectile goes from 0 to a, the vertical displacement from the plane of projection will increases and reaches to a maximum value when the projectile is at a. And the time taken for the projectile to reach from 0 to a is called as time of ascent. Now, how will you define maximum height? The definition for maximum height is the vertical displacement of a projectile during the time of ascent is called as maximum height. The other way of defining maximum height is it is defined as the maximum height to which a projectile rises above the horizontal plane of projection is called as maximum height. This maximum height can also be termed as vertical range. That is, it is also known as vertical range. Now let us derive the expression for maximum height. Let us think in terms of vertical direction. Along vertical direction, the initial velocity is u is equal to u sin phi, and the vertical displacement covered by the projectile is s is equal to h, and the acceleration a can be taken as minus g, and the time taken is which is nothing but time of ascent ta. Now I'll use the formula s is equal to ut plus half at square. Now if I substitute my initial parameters in s is equal to ut plus half at square, I'll get s which is nothing but h, u sin phi, t is nothing but time of ascent ta, a as minus g, that is minus g, t as ta. Then what will I get? I'll get h is equal to u sin phi into Ta minus half g Ta square. Now we know that Ta is nothing but time of ascent and its formula is Ta is equal to u sin phi by g. Now let me substitute the formula for Ta in this expression. When I substitute, what will I get? H is equal to u sin phi into u sin phi by g minus half g into u sin phi by g whole square. Okay. Now u sin phi into u sin phi will become u sin phi whole square. That is, this term will become as u sin phi whole square by g, and 1g will get cancelled. Then what will I get? Minus half u sin phi whole square by g. Now in this entire expression, if I take u sin phi whole square by g as common, then I'll get 1 minus 1 by 2 into u sin phi whole square by g. On doing further mathematical calculation, I'll get the expression for maximum height, which is nothing but h is equal to u sin phi whole square by 2g or u square sin square phi by 2g. This can be written in other form, which is nothing but initial vertical component of velocity whole square by 2g. So the other formula for maximum height is h is equal to u y square by 2g. Now let us derive the expression for range. Okay. Now as the projectile goes from 0 to a, what will happen? The horizontal distance covered by the projectile will increase, and as the projectile reaches a, the horizontal distance covered by the projectile will go to this point. That is from 0 to this point. And from A, as the projectile moves towards B, from here the horizontal distance covered by the projectile will still increase and finally it reaches to B. Okay, so as the projectile goes from 0 to B, the horizontal distance 0 to B in the sense 0 to A and A to B, the horizontal distance covered by the projectile will increase from 0 to B, and the time taken by the projectile to go from 0 to A and A to B is called as time of flight. Now let us define range. What is range? How will you define range? Range is nothing but it is the horizontal distance covered by the projectile during its time of flight. Okay, so the horizontal distance covered by the projectile during the entire time of flight is called as range. Now let us derive the expression for range. We know that along the horizontal direction, the horizontal component of velocity will remain constant. That is, u cos phi is constant. And we already know that if the velocity is constant, the only formula that we can use is speed is equal to distance by time, or distance is equal to speed into time. Now if you apply that formula, that is distance is equal to speed into time, distance is nothing but range, speed is nothing but horizontal velocity, time is nothing but time of flight. Okay, then what will I get? Range r is equal to u cos phi into t, where t is time of flight, and we know the formula for time of flight as 2u sin phi by g. If I substitute 2u sin phi by g instead of t, then I'll get u cos phi into 2u sin phi by g. Okay, so that is this u, I'll bring this side, that is u into 2 2 cos phi and sin phi by g. We know that 2 sin phi cos phi will be sin 2 phi and u into u will become u square. So the formula for range is r is equal to u square sin 2 phi by g. Okay, now let us derive the expression for maximum value of range. Okay, so for a given value of projection, means I fixed u. Okay, range will be maximum when sin 2 phi is maximum. Why? Because for a given value of projection, what does it mean? It means that I fixed u. G is also constant. Okay, so u square is constant and g is constant. Now the value of range purely depends upon sin 2 phi. Range will be maximum when sin 2 phi is maximum. We know that sin 2 phi will be maximum when 2 phi is 90 degrees. That is phi is 45 degrees. So range will be maximum when the angle of projection is 45 degrees. That is, for a given value of projection, range will be maximum when the angle of projection is 45 degrees. Now if we substitute 45 degrees in this expression, we will get the expression for maximum range, which is nothing but R max is equal to u square by g. Okay, so that is one point. That is, range will be maximum at 45 degrees when the angle of projection is 45 degrees. Now let us go to other case where I threw the projectile, or I projected the projectile with different angle of projections, keeping my initial velocity, that is angle of velocity of projection constant. Okay, when I throw a projectile with different angle of projections and keeping my initial velocity constant, then what will happen is, as I increase the angle of projection, what will happen? The horizontal distance covered by the projectile will increase. Initially it will increase. That is, when I start throwing the body from 0 degrees, initial horizontal distance covered will increase, and at 30 degrees let this be the horizontal distance covered. That is, this distance be the range. If from 30 degrees, if I still increase, what will happen? The horizontal distance covered will increase and reaches to a maximum value at 45 degrees. Okay, and from 45 degrees, if I still increase the angle of projection, then what will happen? The horizontal distance covered, that is range, will start decreasing. Okay, and at 60 degrees, I got this distance as range. And if I still increase from 60 degrees, at 90 degrees, what will happen? The value of range will be 0. Now here you can clearly observe that for a given value of velocity of projection, we got same value of range for two angle of projections. That is, the range value is same at 30 degrees and 60 degrees. So at both angles, we got the same range. That means we can obtain same value of range for two angle of projections. Okay, now here we observe that the range is same for 30 degrees and 60 degrees. This 60 degrees can be written as 90 minus 30. That is, the range value will be equal for 30 degrees or 90 minus 30 degrees. In general, we can write like this. That is, the range will be equal when the angle of projection is phi and the angle of projection is 90 minus phi with the horizontal. That is one point. Next point is, this 60 degrees can be written as this 60 degrees with horizontal can be written as 30 degrees with vertical. Okay, that means the range will be equal when the angle of projection is 30 degrees with the horizontal and 30 degrees with the vertical. That means in general we can say that the range will be equal when the angle of projection phi is with the horizontal and the angle of projection, the same angle of projection phi with the vertical. So in both cases the range will be equal.
If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe because your single like and comment will encourage me for making better videos. Thank you.